Okay, so we've had theory papers the whole morning, so finally you get some empirical stuff up here. And I'm also a theorist, but sort of ended up doing some empirical work. This paper has a history as being a prototype, so it's actually not started out as a finance paper. It started out as a software engineering paper that was a prototype for a much bigger project. So I'm going to give you some sense of what that is. But the idea really here is to sort of look into private discussion and emails for various corporations and try and figure out whether you can actually get early signals of corporate malaise. Okay, and the idea here is that you might be able to save a lot of money. So the genesis of this project is that I actually also have another job at the FDIC, and the FDIC worries about bank failures, and we had about 500 bank failures in the crisis. And as part of that crisis, the FDIC collected a huge amount of data. So we actually have emails for the last 10 years in every bank that failed, including board minutes and a whole bunch of internal documents. And the goal was to try and see whether we can actually use those documents, going back and seeing how early we could actually pick up signs of difficulty. And was there some way to wrap that into regulation so that we'd actually be able to use it going forward in an ex-ante sense? So there was tons of data. There's probably several hundred terabytes of data sitting around. And the goal of this paper was to take Enron data and prototype what we do with the bank data and see how that would work out. So this is sort of a weird paper because in some sense what we're doing here is we're not actually trying to set up a null hypothesis and prove it. We're actually going to assume that yes, of course there'll be information in emails that will tell you about stuff coming early, and maybe you should try and disprove that instead of wasting all our time on all this huge amount of terabytes of data. Okay, so the goal of this paper is really a confirmation of what you would expect to see, and are there any wrinkles in that confirmation that you didn't expect to see, rather than trying to say that we've got a hypothesis we're actually trying to disprove. Okay, so it's a slightly different sort of empirical take. It's joint work with So-Young Kim, who's my colleague, and Bhushan was actually my student when this paper was being written, and eventually this paper actually got him a job at Google, so that worked out. So if there's any payoff from the paper, at least there was one. I don't know, this is not working, so. All right, so quickly to just jump through all this stuff, financials generally tend to be sort of delayed indicators of corporate quality. Emails might actually be a good way of picking this up early, and in fact, intuitively should be a way to do that. And the only thing is, of course, you can't have people sitting there and reading all these emails, so you want to use some text mining solution in software to actually do this. And the advantage of that is that because the software is reading the emails, there's no human reading the emails, and in some sense, you get a workaround for the privacy part of it. Okay, so if you don't have to deal with that privacy thing, it becomes a zero revelation mechanism. And the way you build that into regulation is when a bank is getting audited, you usually ask for a whole bunch of audit documents to be provided before the auditors go in. One of the other things you can do is shunt over a bunch of software and say, run this on your emails, and it gives you a blood report of what exactly might be going on with the firm. You can also run this internally if you think it's worth running as management of a company. And so what I'm going to sort of walk you through is a process of building software that actually does this kind of work, and then seeing a few sort of simple empirical things that you get out of it. So we're interested in the sentiment conveyed by email content, the information and structural characteristics, like do we need actually the words themselves, or just sort of features of the types of emails you have, and maybe there's a whole bunch of other non-verbal indicators inside emails that you could actually use as well. Okay, so that's sort of, I'll try and show you a little bit of everything and try and get some idea of what we have here. Okay, so what do we find? We find basically that the net sentiment conveyed by Enron employee email content. Now, these are not all the emails. These are sort of senior management emails, so we don't have each and every email here. Is a decent predictor of stock return performance. The email length, in fact, is a better predictor. So in some sense, we don't need the actual sentiment. The length of the emails is a good predictor as well. And you also find that there are other potential indicators of increasing malfeasance, and I'll try and show you what those are. We haven't finished up the whole thing. The paper was sort of done in April. Has had lots of good comments from referees as well, and now hopefully we're trying to build some more software around this. So the idea is hopefully we'll get all the 500 banks data coming in, and then you can run this whole thing on that, or you put it out and let other management teams run it as well. We got a sample of just 2 years, 2000, 2001. Of course, there's slightly longer samples available, but this was all pulled out under the Freedom of Information Act. A bunch of computer science departments curated the data. And so we're using a curated data set. There are a couple of versions of this data. You can get earlier versions that actually are not allowed for use, more or less, because there's a whole bunch of privacy-related data inside them. The data set we actually have is pretty clean from that. A bunch of redactions have taken place. But there's also things in the data that you actually don't want to read. And when I spoke to lawyers, they said you're actually better off not reading that because it's not very clear what the law says about your reading personal things. There's social security numbers and a whole bunch of private information in these emails. So the good thing is you actually take your zero revelation argument to heart and don't touch the emails with your eyes, and you just sort of let the software do it for you. Okay, so that's, as a researcher as well, it becomes something you do. So these are some of the caveats with the data. As you might expect, this data is not very clean. It's been scrubbed for various legal reasons. The biggest scrubbing problem is Andy Fastow is not in there. And he was sort of the most culpable person, and so his stuff was taken out. We still see the results in here despite his emails not being here, but it would be interesting to have those. There's some stuff around Skilling's resignation that's being expunged, not surprisingly as well. If you actually go look at a few of those emails, you'll find there's a whole bunch of really bad language and things at that time that gets filtered in as well. So the exclusion criteria also not widely known and not made public. Okay, so just these are caveats. The other thing you have to be careful about is which emails you use, and the simple thing to do is just use all the sent emails so you don't duplicate stuff, because every time there's a sender, there's a receiver, and you'd be just double counting a whole bunch of things. So the simple thing is to use sent emails. It also helps you a lot because the way you get the emails is in a tree structure. So you've got all the folders of everybody, and then within that, there's subfolders of emails, so you get this entire tree, and you sort of drill down through the whole tree. And using sent emails actually is the right box to use because you get a whole bunch of filing as well. I get an email, I file it, and I've got a duplication there as well. And so basically sitting and looking only at the sent emails is one effective way of sort of deduplicating the entire data set. We removed a bunch of things that had more than 3,000 characters in length. We sort of had to experiment with that. The reason is that people just take a huge amount of newspaper stuff and forward it to another 100 people, and so that's just news stuff that's not really relevant. So you just sort of filter all those things out. And then anything sent to more than 20 recipients we got rid of because those tend to be blast emails from HR with, saying your tax plan has just changed or your medical plan has changed, things like that. So those are sort of gotten rid of. But you kind of learn while you're doing it. You don't know exactly what to exclude till you actually see all that. Okay? So anyway, I'll sort of leave this up here. But the other thing we did was we want to sort of relate this to news as well. And so we went into Factiva and pulled out all the news articles that we had for those 2 years. 2000, 2001. So just keep in mind that Enron failed in October. That's when they finally filed for bankruptcy. The email corpus actually goes all the way up to 2004 because legal proceedings kept going. But the quantity of email kind of completely drops off from 2002 onwards. There's really nothing there worth exploring. And in any case, we're not interested in what happened after bankruptcy. We were trying to look at it beforehand. So we end up with 144 distinct employees. About 100,000 emails, which is small data now, and it's 2 years, 24 months in total. This is just a schematic of the entire system. So there's an entire software system built around this to do this entire job. So you have a file. All of this was written in R and Python. So we've got a bunch of files coming in, about 1.5 gigs of emails. You parse everything, put them into sort of a data frame, which has a whole bunch of special details in it. And then you can do a whole bunch of cleanups. So in S3, there's another programming piece that does all that, and then we mood score the whole thing. So it goes into a mood score database from which we can actually pull sentiment. Mood scoring is done using the Harvard Inquirer as one source, and then their word list from Lockyer and McDonald that I also use. So these are standard dictionaries for scoring sentiment. And if you're feeling really lazy, you can just take a couple of packages in R, which do sentiment with a one-line function, which we sort of didn't do. We sort of curated the word list that you have. Okay, so it's actually really easy to do this. It's just a matter of being careful about pipelining all the software that you actually build. We pulled return data that we needed. We also constructed networks of how people were sending emails to each other. So we had information about the email network, and we wanted to look and see whether there was any interesting features in how the network of email traffic is changing over time. Keep going, we actually have an entire GUI, so you can get in there and play with different things and track different words over time and so on and so forth. I'll show you some screenshots. And finally, what you do is, on the right, you can see there's something called TDM. That's a term document matrix. That's sort of the standard starting point for any text analysis. You vectorize the entire corpus of all emails, where you have all the words on the rows and all the emails on the columns, but you sort of cluster them by week or by day or whichever way you want. And you can sort of literally put the frequency counts of every word by week, by email in a large number of columns. Okay, there's a giant matrix, and everything then is analyzed off this giant matrix. Okay, the standard sort of text mining stuff. All right, so just to give you some features of the data, we basically have things like the length of email is about 362 characters on average, median is 163. and the total recipients per email is roughly 1 to 2 people. Okay, so this is not bad. That's what you'd expect to see. So it's a sort of validation of the data in general. We also looked at sent mail. So about 11% of the mail generally tends to have sent to nobody. Okay, so the characters are 0. That means they just forwarded the thing off. Right? You got something and forwarded it, so there's nothing above the forward. So we had to write code, actually remove everything below the forward, because that would be double counting as well. And so you had to be careful with that, and that leaves you with a bunch of email that is just simply forwarded and nothing else is done with it. So we've taken a lot of care to basically not duplicate sentiment in any way in any of these emails. That was sort of important. Okay, so if you look at the average email length over time for the 2 years that we looked at, it's about 400 characters per email in the 2000 period, which is before anything started going really long, at least coming out from what Enron had. And then if you look at the 2001 period, halfway through the year, it's pretty much the same as the previous year, and then suddenly it drops. Okay, so the basic length of emails has come down over time, and so you should expect if you run any sort of regression, you're going to get a correlation between email length and the fortunes of Enron. So I don't need to run regressions. It's pretty much there in the pictures. You can look at the net sentiment over time. It's kind of dropping off over time. The way you describe sentiment in text is usually positive sentiment minus negative divided by the total. This is in fact called polarity, if you want the jargon for it. And then you have disagreement is 1 minus that thing, so you should see these things sort of reflecting off each other. Okay, so again, you see this sentiment sort of tracking down. I've smoothed it by taking 13-week moving averages. Otherwise, it's kind of choppy, but by and large, you can see the trend. Okay, so we use dictionaries. I told you about that as well. The news coverage obviously starts increasing as you get towards the end, so that's not surprising. We know that Enron's getting in trouble, and so you're seeing that sort of slight tick up in news coverage towards the end and finally the demise. So that's the other thing you see. We also split the body of the news from the headline of the news, and both of those things tend to track down. So you could actually just run it off the headers rather than running it off the body of these messages, and you'd get pretty much the same results. Net sentiment tracks that, and stock returns keep going down as well. Okay, so these things also should show up in a regression. So the only interesting thing left here is to run a regression and see what drops out and what stays in, and so on and so forth. So if you look at the stock prices as well, or returns is the same thing against sentiment. Okay, this is email length. You get a nice correlation, which you're seeing as well over there. And finally, with stock prices. Okay, so what happens is, the obvious thing is that people start writing shorter and shorter emails when they have less time to deal with it, or they just don't want to write anything into emails, and you're picking that up. So you run a regression on sentiment and stock returns. So this is run actually with a lag. The way it's done is you look at a particular week's return, but you're taking the moving average of the previous 13 weeks. Okay, and putting that on the right-hand side. So it's sort of got a huge amount of lag in there. And so you get 2.3 positive. So it's positive. If sentiment is positive, returns are positive, so they go in the right direction. If you do email length, you also get positive, and you put them together, okay, you find that basically email length kills everything else, but the total number of emails also sort of seems to matter. Okay, so these are what we saw in the actual plots. Okay, so to quantify this, one standard deviation decrease in sentiment is actually associated with a 4.5% decline in stock returns. And it's no longer significant when you control for email length. Okay, a 20-character decline in moving average email length is associated with a 1.17% decline in stock returns. Okay, so don't read too much into this stuff. This is just quantifying something that's in the data, but it doesn't mean that this is sort of some sort of law that's followed for Enron in any particular way. Same thing against the news. So when you look at news, for example, email content contains more information than the news header content. Okay, so the emails are better than news if you look at news headers. But if you look at email length again, it sort of kills off all the sentiment part of it. So email length is something that seems to work. On the other hand, email content contains less information than the header than the body of the news article. But again, when you control for email length, that kills it off. Okay, so basically we're down to just looking at email length. And this is something that shows up in the text mining literature over and over and over again. Okay, so there's a whole lot of stuff in the corporate finance literature where if you actually take the risk words in corporate filings, quarterly filings, in the 10Ks and 10Qs, for example, and you count them up, it's a good predictor of next quarter's down performance. But then you basically find that if you look at the amount of characters in a corporate filing, it's actually a really good predictor of a bad quarter coming up. because companies that have bad news will bury it inside a whole bunch of verbiage to obfuscate it. Okay, so you'll actually get more characters in the quarterly report is a huge predictor of bad performance next quarter. And finally, we discover you don't need to do that anymore. We just go to the SEC server and look at the file size for the upload for the 10Q, and that's all you need. You don't even need to open the document and actually read it. Okay, so it's actually really easy to do this stuff, and so it lends a whole new meaning to NLP because you're now, in some sense, getting a hash of the whole document as a file size, and that's all you actually need. Okay, so we're seeing sort of these similar patterns that have been found in the corporate literature showing up in this as well. We're also interested in sort of looking at just correlations between email sentiment and news body sentiment, different lags. Okay, so over here, if you want to look at sort of the correlation of email and the body sentiment at various lags of email sentiment. Okay, so I'm looking in to see where it's most correlated. It turns out they're kind of contemporaneously correlated. But if you look at lags of email sentiment and how it explains the correlation of email and news headers, it turns out that there's about a 10, 12, 15-week lag at which it actually turns out to be the most positive. But the positive correlation is there, and these things tend to track fairly well. So it's good to know that email length, news, and sentiment from the emails, all this stuff is tracking pretty well, and there is enough information on the lags to give you some bite. Okay, so quick summary so far. We've basically seen that net sentiment conveyed by employees' email is a good predictor, email length is a stronger predictor, and email content may be control manipulated, but it's sort of pretty hard to do. Okay, so that's sort of a conjecture, and we need to see whether, suppose we institute systems like this to actually read email content, then will people change their behavior enough? And it's probably hard to do that with email. It's a sort of generic part of, or integral part of most people's business operations. And we do know that people do try to tell people what they shouldn't be putting into emails, but by and large, there's going to be enough content just from the business side, if it's not sort of culpable content, that actually should be inside emails as well. So suppose we don't want to look at all this and we want to look at other stuff. You might want to look at network structures. Okay, so the networks generally tend to be denser when there's trouble because everybody's starting to talk to everybody else. So in 2000, we have this sort of a network amongst those managers, and it becomes a lot denser in 2001. Okay, so it's fun when you actually see this on a GUI where you can zoom into different pieces of the network and sort of look at it, but hard to sort of do it right here. The degree distribution is interesting. So what's the degree distribution? Every node has a certain number of connections, how many people they're talking to, and that's called the degree of every node in this email network, and that's just a histogram of how many connections you have. So for example, 2 connections, there's a huge, much higher frequency of seeing people with just 2 connections in the network versus 22 connections, so on. Now this is in 2000. In 2001, it changes, the degree distribution changes substantially, so you get a lot of clustering amongst the most important people, and then you get much less later on. Okay, so there's some of this. I really don't know how to use this at this point. We haven't sort of found anything that we can relate it to statistically, so it's just something I thought I'd show you to do. The thing that people like the most when they actually use the system is this word plots, okay? And this is not an original idea. Google Trends has this idea where you put in a particular word and watch it track over time. There's an incredible book called Uncharted, which is based on Google Books. So it's got the entire corpus of Google Books, which is millions and millions of, it's about 35 million books. Every word in all those books is inside the corpus, and all you're doing is, you've basically got all the words and you know what the frequency plot is. Pick a word and it'll show you what it is. And it tells you the story of what's going on with the more important words that you think would explain performance. So I just pulled out profits and losses to show you what they track like in the Enron email database. And so you can see profits sort of go up, and then towards the end they kind of drop off really quickly when the problems begin, and losses is exactly the opposite. So you're seeing the word losses show up at a much higher frequency as it gets into trouble towards the end of the period, and profits actually is coming down. There's a lot of other things you can do with it, but that's just a screenshot of the system. The other thing people do with this is topic analysis. So if you take all the emails that you have and you want to figure out what are the most important topics over time across the 2 years, and how is the frequency of emails within these topics changing, and then you can sentiment score each of these topics. Okay, so think of what if you took basic data on, let's say, interest rates over time for different maturities, and you did a principal components analysis, and you got, let's say, the first 3 important principal components. In the text space, that would just be the topics that you uncovered, except it's not as simple as doing principal components. okay? But really speaking, conceptually, that's sort of the idea. Now, what we do is we take all the documents you have and we put them into a vector representation. So this is the term document matrix that we had. Terms are words, so those are on the rows. The documents are all in the columns, and all you have in the cells are the frequency count of how many times a word appears in a particular document. That's basically the starting point for any search engine as well. Okay, you basically have a term document matrix, and search engines feed off these sorts of matrices. What we're going to do with this is we're going to actually construct topics, and I'll not spend too much time on all the math of it, but there are two steps that we normally perform. One is you do something called latent semantic analysis, which is reduce the dimension of the space. And the way that's done is by taking that matrix we had for the term document matrix, or if you transpose it, you get a document term matrix, which is documents on the rows and words on the columns, and you do a singular value decomposition to actually reduce the dimension of this matrix. And so you get the reduced dimension matrix, and then you submit it to sort of so-called principal components analysis. So let me just jump to that. And this is a system called LDA. LDA is something that's almost like 15 years old now. It came out of Berkeley. It was David Blair's thesis. And the idea here is to take that term document matrix, and it's got words and documents, but we want a latent factor, which is topics. And we're trying to extract what those latent factors actually are. Okay, so let's say I pick 5 topics, and I'm going to take this data I have on words and documents, and then sort of map it to a bunch into a 5-topic space. And so there's a latent dimension, which is the third dimension. So I'm going to take my term document matrix, okay, and split it into 2 separate matrices. So in fact, let me just jump there directly, if that might be the best thing to do. Yeah, so this is what I want to do. I've got a matrix A, which is not term document, but it's documents times topics. Okay, so the documents are on the rows, and all the topics, 5 topics would be 5 columns. And in each cell in that matrix is going to be the probability of a given document being in each topic, and the rows should add up to 1. Okay, so that's a latent matrix now, because I don't know what the topics are, and I don't know what the cell numbers actually are, but I know there should be probabilities, and the rows should add up to 1. The second matrix I'm going to have is B, and that matrix is topics times words. So topics on the rows, words on the columns, and those rows sum up to 1. So I basically have a probability, if I take a row which is a particular topic, what's the probability of all those words showing up? So if I have 50,000 words, then each one will have a probability of being in that topic. So I have that second matrix. If I multiply matrix A by matrix B, I actually recover my document term matrix. Because you can see this is a M by K, which is basically documents into topics, topics into words. If I multiply A times B, I get documents into words, which is nothing but my document term matrix. So I'm actually going to try and take the term document matrix, or the transpose of it, and factorize it into 2 matrices, A and B, which I don't know. But I have constraints on the cells in that matrix, because they have to have rows that add up to 1 and are actually probabilities. So I need to put a probability function on these cells, and the function that's put is the Dirichlet function. And so that's why it's called latent Dirichlet attribution, because you basically got a latent set of topics. You're using the Dirichlet probability distribution and doing some attribution to it. Okay, so this is sort of in the space of hidden Markov models, and it turns out you basically maximize the likelihood function that looks like this across all the documents. So we're taking the entire corpus of documents and trying to maximize one likelihood function. Turns out there's lots of good commercial software for doing this. You don't have to kill yourself trying to fit this thing. And so we fit it, and we actually get a simple picture like this. So notice, I pre-decided I want 5 topics. Over the 24 months in this sample period, I've got different colored proportions of the topics. And if you look at, there's a lot of blue out here in the beginning, and that's topic 4. Topic 4 has a positive sentiment, because what I can do is take all the words in those topics, sentiment score them, and I know which topic is a positive sentiment topic and which topic is a negative sentiment topic. As you get towards the end, you start seeing basically topic 2 showing up a lot, and topic 2 comes in with a pretty high negative sentiment. Okay, so you get positive sentiment topics leading to negative sentiment topics later. This is slightly off topic, the paper itself, but we actually implemented this in India with the central bank, and worked with a startup called Topics, and we kind of built something where we would read in about 100, 200 news articles every day, and the map shows you where those news articles were coming from, which cities. The circles tell you how much of the news flow from that city was positive sentiment, neutral sentiment, and negative sentiment. And then we would break it into topics. So you can see, of course, Raghu Rajan is one of the people that shows up a lot in the words that's there. and we actually find all the top topics that show up with the sentiment scores on it. Okay, so this topic analysis is a good thing to do. You can actually extract sort of latent topics that you didn't really know about, but you want to know what people are generally talking about. Companies can do this as well, because the nice thing is if you do it every week and you say, let me take all the press about my firm and break it down into topics, you can also look at within each topic and see what the most important words in each topic are, and then you decide, okay, that topic must be about, growth. It's just like principal components. You have to look at the time plot of the factor that you extract and then try and decide what exactly is it, but it's sort of the same thing over here. Okay, so it looks like I'm out of time, which is good because I'm going to end with a movie, and hopefully this should be fun. So while this is running, hopefully it is running. No, that's not good. Let me close this. Whoa. All right, here it is. Hopefully it'll work. All right, so this is a movie of email traffic from 2000 through the sample period. On the left is the quantum of negative words that's coming up. What do I click over here? Okay. On the bottom is the positive sentiment emails. On the right is litigious ones based on Lockyer McDonald's litigious word data set. And at the bottom is the uncertain words. Around the ring is all the different people who are in the email database. And you can see the email traffic going. Around the ring, you can see the quantum of emails that a certain person is sending that actually has positive sentiment, negative sentiment, litigious sentiment, and uncertain sentiment. And if you read below the big ring, there'll be news flashes that are picking up the Factiva news articles and producing this movie of all the Enron stuff. Now, I didn't do this. This was done by my friend James Callahan. Okay, when James read the paper, he said, oh, that's cool. I'm going to just try and write some code. And he went off and produced this thing and sent it to me. And in one stroke, I realized, one movie is better than hundreds of words in my paper. Works a lot better. But he comes from the visual effects industry. So it's pretty natural, for him to do something like this. So anyway, the whole thing runs, and you can kind of read all this, and you can see that stuff started going to get redder and redder and redder up in that corner there as you're watching the whole thing, fill out. And then you're actually seeing whether people are, who's saying good things and who's saying bad things, right? Because the red lines going between people are going to be, so now there's suddenly litigious stuff you saw coming up and so on and so forth at the end, right? Because you'd sort of expect that. All right, thanks a lot. I'll stop here.